Hello there. One of the first things you'll learn in univariate statistics is how to create a frequency table. You'll begin with an individual frequency table. In an individual frequency table, you have a bunch of values, and typically the top of the table will mark them as X. Let's do something simple. Let's pretend we've got quiz grades here. You can get grades on a scale from 1 to 10. So you have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And you get that last point for showing up even if you get everything wrong. Now let's do frequency. F is the heading for frequencies. And let's say 3 people got 10s, 7 people got 9s. Let's go 4 people got 8s, 6 people got 7s. Let's say 2 got 6s, 0 got 5s. We'll have 3 for 4, 2 here. Let's see, that's 20, 25, 7. Let's say we had 1 and 2 2s. That should sum to 30, but we'll find out in a moment. We'll find out because the next column is our cumulative frequency, often abbreviated CF. We begin at the bottom here, and we take our frequency, and for the first time we just drag it right across. The frequency of the values 1 and below is 2. Now to find the value of the frequencies for the scores of 2 and below, we take our current cumulative frequency and we add the frequency for the next value. 2 plus 1 is 3. This continues all the way up. 2 plus 3 plus 2 is 5. 5 plus the 3 is 8. 8 plus 0 is 8. 8 plus 2 is 10. Plus 6, 16. 16 plus 4 is 20. 20 plus 7 is 27. And 27 plus 3 is 30. So we have the number I intended. If you know how many values you have here in your frequency, you can use that to double check your cumulative frequency, because this number should always be equal to the total number of the frequencies. Next, we have our relative frequency. For relative frequency, we take this frequency column and we divide that frequency by the total number of values. So for here we have 2 divided by 30 is equal to 0.0666667. I'm only going to deal with 3 decimal places, so we'll call this 0.067 with a slight rounding up. Then we come up here, we have 1 divided by 30. That's equal to 0.033. I'm not going to round that up because none of the values are greater than 5 or equal to 5. Next we have another 2, so I'm just going to take my 0.067. Since that's the number that would go with that, we have 3. 3 divided by 30 is equal to 0.1. Then we have a 0. 0 is equal to 0.0 or just 0. I just like to have the decimal there to remind myself that there's nothing to the right of the 0. Then we have 2 again, so 0.067. Then we have a 6. 6 divided by 30 is equal to 0.2. Then we have a 4. 4 divided by 30 is equal to 0.133. Again, not rounding up because nothing is equal to or greater than 5 in there. We have 7 divided by 30 is 0.233. 233. And then finally 3 again, so 0.1. Now, this tells us roughly how frequently each of these occurs. So just looking through here, we can tell that this is the most frequent and that this is the least frequent. Well, the least frequent of the occurring scores. This is absolutely the least frequent, but it's because there were no scores there, and I was thinking about values that had a frequency greater than 0. Our next column is our cumulative relative frequency. This is just like our cumulative frequency column, except we're dealing with our relative frequencies instead of our numerical frequencies over here. So we're going to have 0.067. Then we're going to add the 0.033. Let's see. 0.067 plus 0.033, as I thought. 0.1 plus 0.067 is 0.167 plus 0.1 is 0.267 plus 0 is still 0.267. Let's see. 0.267 plus 0.67 is equal to, messed that one up, 0.267 plus 0.067, there we go, is equal to 0.334. 0.334 plus 0.2 is equal to 0.534. 0.534 plus 0.534 plus 0.133 is equal to 0.667. 0.667 plus 0.233 is equal to 0.9. 0.9 plus 0.1 is equal to 1. So this is how we can tell that this column was done properly, is that the final highest value is equal to 1. Since we're dealing with decimals, and these decimals represent portions of the entirety, the 30, our cumulative relative frequency for the highest value should always be 1. And that's because our cumulative frequencies tell us how many scores are equal to and less than the value. So the values that are equal to or less than 10, the maximum value, is equal to 1, all of the values. Just like if we came down here and we said 6, the scores that were equal to 6 are 10, and that cumulatively they account for 0.334 of the total values. Or if we converted this into a percentage, like we could do, about 33% of all our values were equal to or less than 6. And indeed, we can convert all of these into percentages. We'd have 100%, 90%, 66.7%, 53.4%, 33.4% like we just did, 26.7%, 26.7%, 16.7%, 10%, and 6.7%. There you go. That's how you complete a cumulative and relative frequency table using individual values on the side. Next time, we'll go ahead and take a look at interval frequency tables, why we'd use them, and how to calculate everything that goes along with them.